Okay, we're going to look at 15.3, which is double integrals and polar coordinates. And so here we go. I'm going to get to the paper view. And so just some initial comments. Why, oh, why, I say, would we ever want to use polar? And the answer to that is it makes some volumes easier to calculate, and it makes some volumes possible to calculate. And when would it be better to use polar? When the region you are integrating over is circular. And then I have some different circular regions here. So that's a fourth of a circle. And we would run our R from 0 to B, whatever that circle is, the radius of that circle, 0 to B. We run our theta from 0 to pi over 2. And then here we have just a sector, and we would, they've given us a radius of B. So again, radius goes from 0 to B, and we're going from alpha. So this line right here is theta equals alpha to this line here is theta equals beta. And so, and then here's another one where our region starts out here some distance A. And so our region for our R starts at A and ends at B. And so we're looking at this little washer part. Our theta is going from alpha to beta. So anyway, so that's kind of what we have going there. And I'm not going to show the video that I have here, but if you want to go watch that video, you certainly can. The reason I'm not going to show that video here is because then my video will probably be copyrighted struck. But anyway, x squared plus y squared equals r squared is some things that we need to know about polar. And x equals r cosine of theta. And y equals r sine of theta, and tangent of theta equals y over x. And I saw a problem in your book that had given you the arctangent. So tangent, arctangent, written, I guess they probably wrote it arctangent like this, but either way, it doesn't matter. And then they said of y over x. And so they said y over x here. And I was thinking, oh my gosh, if I could just get that somehow in either r or theta, that'd be so great. And then I was like, that's equal to theta, right? So just a warning on that when you're trying to transfer in if you do some of the homework problems. Now, one of the things that it's pretty clear cut of what to do in that you're going to take all of your x's, and if you have x squared plus y squared, you're going to replace them with r squared. If you have x only, then you replace it with r cosine of theta. And so all of that is all really clear. And this was one of the tricky ones up there. But what's not clear is why does dA get replaced with r d theta? And this video explains that in 2 minutes. And so I'm going to try to explain it in 2 minutes as well. So they start off with a tiny rectangular box when we were in rectangular. So when we were in rectangular, and I don't know if you remember that we made a grid and we split it up into a whole bunch of rectangular boxes. And we're going to make this box really small. And so that's the idea, really small. And so this had, some change in x and some change in y. And we said dA equals dx times dy is what we said. And that was the area of that box. So now we have this, and we've made this, they call it polar rectangles, and we've divvied these all up. So we've taken this region right here, and we've divvied it all up, right? And we've created these little rectangles. And these little rectangles, if I look at them big, they're kind of curved like this. But as I zoom in and make it smaller and smaller, it becomes looking like a rectangle. And remember, that's what we're going to do, is that we're going to zoom in. So we're not looking at a big one. We're looking at, so that we can see the curve, we're looking at zooming in and getting a really small one. And so they say that you can zoom in to a point that this is equal to dA. And when I do that, this region here, that's the arc of my sector. And I don't know if you guys remember from geometry, but the arc of your sector, the length of this, right, of that sector, that arc, the length of that arc was equal to, in this case, I have what the angle is, which is the change in theta, multiplied by the value of how long this is. And how long that is, here, I'll add it on here as well. How long that is, ooh, I could get it to a thing, is r. And so this length of that sector right there is equal to r d theta, is what that length of that sector is right there. And then this was our r, and so this was r, and on this other side as well is our radius. And then this is our little bit of change in r as I made it just a little bit bigger. So this is our dr. And so if I put that on here, that's dr right here, and this is r d theta, right? And then I'm looking at the area of that, and it is multiply them together, right? R d theta dr. But of course, a better order for that would be r d theta. It kind of rolls off your tongue too really nicely. So that's the reason for it. And hopefully that was not much over 2 minutes. And so I'm going to put this paper here and hopefully not lose it, but who knows with me. Might lose it. Oh, why are you not focusing? What is wrong? What is wrong? What is your problem? Please focus. If it doesn't focus pretty soon, I have to call Kevin. Oh, if I put my hand under here, will it do better? Okay. It felt alone, and it said, wait a minute, I'm all alone. Okay, so this is example 1, and so we're going to check out example 1. And I just want to remind you, I'm just going to put that up here. X equals r cosine of theta. Am I right on that? Check it out, make sure. And y equals r sine of theta. And what I want to do is, so this is my height, is what this is z equals, right? So this is f xy equals xy, and which is equal to z. And so I'm trying to find the volume, and this is my height. And so I'm integrating the each height with the value of the area for each rectangle is what I'm doing. So I want to draw in 2 dimension, I want to draw this. So x squared plus y squared equals 4. So if I draw this here, it's a circle. And radius of 2, right? So radius of 2. And then I want to also draw on here y equals x. So here's y equals x. And also I want to draw on here x equals 0. And so we're looking at the region that's bound by these 3 things. So if I'm looking at, well, what region got bound by those 3 things, and I'm drawing them all, it's this region right here, right, that got bound by all 3 things, that little slice of pie right there. Okay, so if I wanted to, and I just want to show you this, and I have room, I'll redraw it. But if I wanted to get crazy, I could say, well, this line right here is y equals x. And that's this line right here. And I'm going to be going, if I go vertically up, and I'm going to be hitting that circle. And I need to solve that circle for y. So that would be x squared plus y squared equals 4. And so that would be solving for y. Y squared equals 4 minus x squared. So y equals plus or minus the square root of 4 minus x squared. And I don't have to worry about the negative because it's in the first quadrant. So y equals the positive of the 4 minus x squared. So if I wanted to be brave, I could do this in rectangular. But the problem is that this is going to be my upper bound. And then I'm going to plug that in after I do the integral here, right, with x and y, which is no problem at all. But I'm going to be plugging this in for y, and it's going to create that. And that's going to be something that I would have to be able to integrate. And so, and maybe, maybe I would get lucky and have maybe an x on the outside. If I did get lucky, then I could use a U substitution. If I didn't get lucky and had an x on the outside, maybe I do get lucky on this one and have an x on the outside, then I would have to use those triangles. I don't know if you guys remember those triangles where you did the trig substitutions with triangles in Calc 2. And so that could come up in here. And, if I could avoid that, I would like to avoid that because that was pretty hard. And so anyway, and so I am going to turn this into polar. And so if I turn this into polar, so I'm going to just kind of draw our little region in here that we have. And so this is here. Do you guys agree that in polar, I have my equation x squared plus y squared equals 4. So that equation is r squared equals 4. Do you guys agree? Because x squared plus y squared is r squared. And so that becomes r equals 2. And so this is right here, the radius of that circle too. And you knew that already, right? And so that's good. And so my bounds for r, as I turn this into polar, are going to go, this whole region is my shading. And so I'm going to start here, and my r is going to go from 0, so starting here, all the way to 2 is where it's going to go. All of the r's that I would draw, infinitely many of them, right? Those little radiuses that are going to make my grid, go from 0 to 2. So I know that on the bounds for r, I'm going from 0, I'm going to write it like this, to 2. Now I would like to get going on theta, and this line right here was y equals x. And everyone was shouting out at me that, hey, that's pi over 4. And I totally agree with you. But if you're sitting there saying, how did they know it was pi over 4? I want to show you a way that you would know that that is pi over 4. Because now I'm going to go with my theta. And so this angle in here, theta, is what I'm trying to find right now. And remember that we know that tangent, well, should I say theta equals and then equals tangent? Would that be okay? Either way, it doesn't matter, right? This is one of the other things that we knew, that theta equaled tangent of y divided by x. Now, in this case, y and x on this line are equal to one another. So theta equals tangent of, I'm going to replace y with x because that's on this line. So this is x over x. So theta equals tangent of 1. And I don't know if you remember that the arc tangent, right? Did I do that wrong? I did do that wrong. I've had a hard day. Forgive me if you can. Tangent of theta equals y over x, right? That's my given property. And then tangent of theta equals x over x. Tangent of theta, sorry about that. I don't know what I got crazy on, equals 1. And then arctangent of 1 equals theta. And then you could do that in your calculator if you like, or you can do it in your head. But that would mean that theta equals pi over 4. So that's kind of clever. And so that is our starting theta right here, which I think they called alpha, is what they called it. And then I want to have my ending theta. Now my ending theta is going to go to here, and that equation for that is, x equals 0, right? So that's x equals 0. And I just want to show you, so I know that you know that it's pi over 2, but I just want to show you if you solved it. And so I'll go a little bit faster. So tangent of theta equals y over 0. And so that is asking us, when is the tangent of theta equal to undefined? And I know that the tangent of theta is undefined at 2 values, pi over 2 and negative pi over 2. And so from looking at it, that, hey, theta is pi over 2. So, so we have now our bounds for r, 0 to 2, and we have our bounds for theta, pi over 4 to pi over 2. So this volume is going to become, so the volume is going to become the integral, and you do r dr d theta. So we're going to put here our r dr d theta. So you always start on the inner integral with your r's. And so they are going from 0 to 2. So r equals 0 to r equals 2. And on your thetas, you go from, it was pi over 4 to pi over 2. So theta equals pi over 4 to theta equals pi over 2. And I like to write what it is so that I don't forget. That's just me. You don't have to do that. Now we had xy, and this was our dA, is what this is. dA is r dr d theta. So what was x? Well, it was r cosine of theta. And what was y? It was r sine of theta. So I'm going to squeeze this in here, r cosine of theta times, and I'm going to have to erase to squeeze it in, sorry, times r sine of theta times r dr d theta. And then I just want to clean it up, and then I'm going to be taking the antiderivative with respect to r first. And you notice we have r, that's r to the third. So our volume is our integral from pi over 4 to pi over 2 of 0 to 2 of r cubed sine of theta cosine of theta. I don't know why I wrote sine first. It doesn't matter though. So cosine of theta times sine of theta dr d theta. And then what I'm going to be finding, I'm going to put a box around it right here, a purple box. Oh, my purple pen. I'm going to find this. So that's what I'm finding first. And I'll put a purple box around it. So I like to put it down. Now I'm only taking the integral with respect to r, and theta is a constant. And so if I liked right now, I could move cosine of theta and sine of theta, but because they're constants, I'm going to see if my blue pen will work. And I could move them in between, right? And so I could move them out of the integral that is dr, because they're a constant compared to r. And so I think I will do that. And so now I'm going to be not doing too much in pen because, you know, I'm a math person. And so we're going to get the integral of r to the third, which is r to the fourth. Hopefully I don't make a mistake after I say I was a math person, from 0 to 2. And so that's going to give us 2 to the fourth, right? Upper bound minus lower bound, fundamental theorem of calculus, which is 16 over 4 minus 0 over 4. And so this is equal to 4. And so now this is my work that I had here in purple just to do that part, right? And so all I did was that, right, after I moved the integral out, the cosine sine thing out in front. But this box is that work. And from that, I just simply get 4 is what I get. So now when I go to integrate this, volume equals, now this is for theta, pi over 4 to pi over 2. And you can write theta there. I often do. And we already had the cosine of theta and the sine of theta, d theta. So we already had that part because we moved that out in the front. And what are we going to put there with that stuff? 4. Now 4 is a constant, so if you like, you can put 4 through the integral, and that would be just Jim Dandy if you wanted to do that. And so I'll put that eraser there. Maybe it will focus in on that eraser and keep focus even if I move my hand. I don't know. It's acting weird. And so I'm going to have to do a U substitution. Now, the other thing I could do is, if you liked, instead of a U substitution, I could do a trig substitution here. Because I know that 2 times sine of theta cosine of theta is equal to sine 2 theta. And so that would also work. I'm not going to get too tricky. I'm going to do a U substitution because, hey, I got choices. I could do a trig substitution if I liked, but I think I'll do a U substitution. You do whatever floats your boat. So U equals sine of theta, du equals cosine of theta, d theta, right? And I see that sitting right there. There it is, cosine of theta, d theta, and I'm going to replace that with du. Then my bounds, I like to go ahead and do my bounds. And so my low bound is, remember, it's theta equals pi over 4. And then we know that u is linked together with theta through this formula. U equals sine of theta, u equals sine of pi over 4, which is the square root of 2 over 2. You can do that on your calculator if you need to. And then the upper bound is pi over 2. So theta equals pi over 2. I'm going to u and I'm not going back. And so sine of pi over 2 equals, now the sine of pi over 2 is equal to 1. And so we're going to get, when we put this all together, we're going to get our volume equals, now our bounds, our lower bound was square root of 2 over 2. Our upper bound was 1. You can't put them in order because it might not be in order. And so you can't put them in numerical order here. You have to put them in what they were, up bound and low bound. And then you just don't need to worry about it. Fundamental theorem of calculus will take care of it. And so I have 4 sine of theta. And remember, we were replacing sine of theta with u. I'm going to put the 4 here in the front. So u. And then I'm replacing cosine d theta with du. So see that? I'm replacing that with du. So this becomes u du. And then I can integrate that. That's going to be 4u squared over 2, which equals 2u squared. I put the 4 out in front, right? And u squared over 2. So that's 2u squared. And I'm going to be going from square root of 2 over 2 to 1. So fundamental theorem of calculus. 2 times the upper bound, that's 1 squared, right? And I'm going to multiply this by 2 minus the lower bound, which is, you can do it however you want. You can put the 2 in both of them, or you can put the 2 out in the front, whatever floats your boat on that. I don't care. It doesn't matter to me. Probably would be putting this in my calculator probably anyway. And so when I do this part right here, I get 1 and I get take away. And then when I square it, you can put it in your calculator, you get 2 over 4. Now 2 over 4 is half. So this is 1 take away half, which is half. So this is 2 times half, which is equal to 1. So our volume is equal to 1. And so what we have found is that z is coming out of the page. And for every point in here, every x and y point in here, there is a certain height. And the height of every single point in here, it's looking like it has the chicken pox. But for every single point in here, the height is x times y. And so I'm over just a tiny bit. I don't know, x is 0.1. And y is, it's above the line x equals y. So I'll say y is 0.2. And so the height of that is 0.1 times 0.2 for that little example. And so anyway, so that's kind of that story. And we have, how many heights do we have in there coming out of the page? We have infinitely many, right? And then if we find the volume of all of those, and so these are all little, infinitely many rectangles, so small, little rectangles so small, infinitely many rectangles so small, but they have, when you add them all up, a volume of 1. And so anyway, so that's kind of the story there of what we found. And so I just put a little note. We just found the volume under the surface, z equals xy, on this little sliver. And then I don't know why I laughed. I don't know. It wasn't funny. But anyway, okay, so that's one. We'll give ourselves full credit. And then we're moving on to example 2. And on hand in the page, sorry, I don't know why it's not focusing. And so they're asking me setup only. And I did put the answer down here. You finish it, and the answer is 17 pi over 2. Just for time's sake. I guess because I'm making this video that I don't have the time crunch that I have in class. Oh man, I hope I didn't solve it in class. I bet I did. That just, no, you know me. Oh my gosh. Anyway, not following the directions. So find the volume between z equals 9 minus x squared minus y squared and the xy plane. Now the xy plane is another way of saying z is 0. So we're going from z is 0 to z equals 9 minus x squared minus y squared. So we're having all the, and it's probably not smooth, you know what I mean? And so that's going to create our volume as bound by the cylinder x squared cylinder. Oh yeah, it is. If you graph it in 3D, it is a cylinder, right? But I'm going to graph it in 2D. And so I had forgotten about that. Oh my gosh, the focusing is really having trouble. I might have to call my tech support at some point and see what they say. Okay, so we get 1. I know that it's a circle, so I know that it would be better if I go, if I do polar. And this is all that it's bound by. So this is the whole circle. So there's no other things, right? It's the whole circle. So my radius r, well, the circle r squared, right? X squared plus y squared equals r squared. I got hiccups, I'm sorry. Equals 1. So the radius is 1. You already knew that. And I'm going to be going from 0 right here out to 1. Everywhere from radius of 0 out to 1. Radius of 0 out to 1. Radius of 0 out to 1. So that's what I'm going to be doing. So my radius is going to equal, it's going to be trapped between 0 and 1 is what my radius is going to go between. And so from 0 to 1 to get all of the points, right? I'm going to get all these points in here. And where is my theta going to be going? Well, my theta is going to be going from here. And if you wanted to, that's y equals 0 all the way around to y equals 2 pi. Is that okay? From theta equals 0 to theta equals 2 pi. And so, because it's going to be all this whole entire circle. So 0 for theta to 2 pi. And so now I'm going to set this up. My z right here, this is my z is equal to, I don't want any x's or any y's, 9 minus, and then this is x squared plus y squared. So convenient, because that's equal to, that's equal to radius squared. So my z is 9 minus r squared, right? So this is 9 minus r squared, 9 minus r squared. So I want my height to not have any x's and y's in it. So this is my height is z. I want my bounds to not have any x's and y's in them. I want it to be for r and theta. So my volume will be, remember that part of the deal here is that it's r d theta. That's what's replacing dA, right, in my function that I would normally have for my volume, which was the double integral of fxy dA. And so what's replacing dA? R d theta. Chant that to yourself. My r's are going from 0 to 1. And my thetas are going from 0 to 2 pi. You shouldn't use symmetry in these because you don't know that you have symmetry of your surface. And so you might have symmetry of this thing. So only if you know you have symmetry of your height could you use symmetry. And so we're going to have 9 minus r squared right here. So 9 minus r squared times r d theta. And now we're ready to go to integrate that. And so I said setup only. And so if I said setup only, this would be done. Here is the setup. So at setup only, we're done. And you're saying, well, why so much room? Well, why so much room is because I said to you, hey, give it a try, solve it yourself. And so, and if you want to try it, you could pause the video or you could fast forward to the next problem if you want to be on setup only. But I'm going to practice my solving it here. And so I'm going to have here from 0 to 2 pi. And then I'm going to multiply that together. That's 9r minus r cubed dr d theta, right? So I multiplied, distributed in the r. And where did my integral go? Right there for 0 to 1 on r, right? And I have to remind myself that's r, that's r, that's r. And I'm going to put a little parenthesis there. And so now with my purple pen, I'm going to circle what I'm first going to integrate. And I am integrating this part. You do you, but what I like to do is make a little arrow there and then say that I'm doing that part. So I don't have to write all the stuff down. So 9r squared over 2 minus r to the 4th over 4 from 0 to 1. And so that is equal to, when you put in 1, so upper bound minus lower bound, but if you put in 1, you get 9 over 2 minus 1/4 minus, and then when you put in 0 for the lower bound, fundamental theorem of calculus, right, I get 0. So I should know what 9/2 take away 1/4 is, but not today. And so I'm getting my calculator out. So 9/2 take away 1/4, and it's 17 over 4. And so we're going to have, so we just did this work right here. And our integral, oh, I didn't write 17 over 4. Just checking you, 17 over 4. Anyone got any white out? So I could white out that line that I put there. And so now my integral, my volume is going to look like, so I'm going from 0 to 2 pi, that's for theta, and you can write theta in there if you're worried you're going to mess it up, of 17 over 4 d theta. So just exactly what we got there is going to go there. And then if I integrate that with respect to theta, that's going to be 17 over 4 theta from 0 to 2 pi. Up bound minus lower bound. This is going to be my volume, right? And so this is 17 over 4. And then 2 pi take away 0. So this is 17 over 4 times 2 pi, which equals 17 over 2 pi. And that's my volume, right? So that's my volume here, 17 over pi, 17 pi over 2. And that's what I said, hey, the answer would be. And so, and we just finished it. And we did a lovely job at that. And that one wasn't actually as hard as the other one, I don't think, but because we didn't have to do a U substitution or anything like that. But I just had said you finish it because of time. And so that was the reason. This is another one that's set up only, and I'm having us set up only because of time. And so we have z equals, and so this is that curve that's above the xy plane where z is 0, right? So z is 0, and we're getting this volume, and it might not be level, and probably isn't level. And then we're going to integrate it over this region that's bound by these two circles and cylinders because it's going to go up and hit, right? And so, but I'm going to draw them in 2 dimensions, so I'm going to call them circles. So this one here, do you guys agree this is radius squared equals 1? And so that is the radius equals 1. And so you knew that, x squared plus y squared equals 1. And so that circle, that's that circle right there. And then this circle right here is radius squared equals 2, so that the radius equals the square root of 2. And I'm going to draw that one on there as well. And so this one was here, right here, radius of 1. Square root of 2 is 1.4. And so that's just out a little bit here. Man, I draw these so good. I know what you're thinking. That you wish that you were as artistic. And so now we're looking for the area that is trapped by both circles. And so that's this little washer in here. You know why I'm so hungry? I haven't had dinner. And that's my next goal. Do I need to write it down, or do you think I will remember it? I think I probably will remember it. So now our radius goes from here, right? So I'm starting here in the center, and I'm in air, and I hit the curve at r is 1, and I continue through so that I'm interested in the radius going from 1 for the radius to the square root of 2. Is that okay? And then I'm interested in going around the entire circle, and I'm centered at the origin. And I'm going to tell you that right now, that if you're not centered at the origin, you have to be more careful. And so let me say it again. If you're not centered at the origin, you have to be more careful. In a little bit, we're going to do ones where you have to be more careful. So since I'm centered at the origin, and I'm wanting to know where does my theta go, my theta goes from 0 all the way to 2 pi. So 0, this is theta from 0 to 2 pi. So on setup only, I'm going to have my volume equals double integral, and our theta goes from 0 to theta equals 2 pi. Theta is always on the outside. You always do it in this order, r d theta. Always is the order that you do it in. And so 1, r goes from 1 to the square root of 2. And then I want to put my z in there. And I'm noticing, well, z is, oh my goodness, what is z? And so, well, the denominator is r squared, so I can put in the denominator r squared, and this is times, right? And then the numerator is y squared, and I don't know if you remember that y equals, what was y? It was r, was it sine or was it cosine? I hope that you remember, because I'm stressing myself out remembering. Actually, I know that when I did this one time, I was doing this problem really quickly, and I accidentally put in cosine, and I was in, like, got something I couldn't integrate. And then I was like, when I did this problem before, it's like the 5th time I've done this problem. So if you're like, how many times have you done this problem? Well, 5 times. And I know that at least one of those times, and not the first time, I accidentally had something wrong in here. So this would mean that y squared equals r squared, I'll stop talking to myself, times sine squared theta. No, I'm talking to you. I forgot who I was talking to, right? I'm talking to you, lovely people. You're beautiful. Let me say it again. So I'm going to have up here r squared, sine squared, because this was y squared, right? And so I'm replacing in there. So sine squared theta. And then good news, r squared divided by r squared is 1. And so I'm left with this volume. Setup only. I think you should reduce even on setup only. That would make me feel better about you. I know a lot of you have learned somewhere that reducing is not something that you have to do. And that is the reason I shouldn't be talking smack or anything like that. But that's the reason a lot of schools are not liking to take calculus classes that don't have students reduce. And so this is r sine squared theta dr d theta. And sine squared theta, friends, I know that if it was set up only, here we are, set up only, we're done. That's our answer. I think that you should reduce it up just a tiny bit. Did I reduce that other one that was set up only? I don't know if I did or not. Here, I'm going to look. I left it as 9 minus r squared times r. I think that's okay. But, I mean, things that clearly reduce. I think I should reduce it up a bit. And so, if it was set up only, I'm done. Now that I'm going to try to convince you that I'm going to help you do this. So if you wanted to do it on your own, pause the video. And so I'm going to be taking the integral here that I'm putting a box around. You do you. This is how I do it. And so I don't know if I was in Calc 3, if I put these crazy boxes around it. I'll call Mr. Moretti today. He was my Calc 3 teacher, and I'll ask him. Do you guys notice that doesn't have R in it? So I can move it right through the integral, and I plan to do that because it'll make it easier. So I'm really only integrating R as all that I'm integrating in my little purple box here. And that's easy to integrate. That's R squared over 2. 1 to the square root of 2. I'll remember that's R. I only have that going on, so I think I'm okay. And that is equal to the square root of 2 squared over 2, up bound minus low bound, 1 over, I'm about to do that wrong, forgive me, 1 squared over 2. So this is 2 over 2, which is 1, and then this is 1/2, so 1 minus 1/2 equals half. So that's lovely. And I'm going to put the purple box around it because that's what I just found, right, in the purple box. So I can substitute in purple box into purple box, right? And of course I moved this with the blue. So I'm going to have the volume equals theta to 0 and theta to 2 pi. And I'm going to have half and then sine squared theta d theta. And this one, like the other one that I had, I could do a U substitution, or I could do trig identity. This one I only have the choice of doing a trig identity, and this is the trig identity that I'm going to use to do it. So this is the trig identity that I'm going to use. Sine squared theta equals half times 1 minus cosine 2 theta, and I have memorized that, and I suggest that you do as well. And so I remember that when it's cosine squared theta, that it's plus, and then when it's sine squared theta, it's minus. And I don't know, I don't even have a song for it. It's terrible. I need a song. Write me a song, and I've turned off the comments, so you can't put it in the comments, but you can send me an email with the song so that I can remember this trig identity. Now I'm going to be replacing sine squared theta with this right here, and you guys agree I'm going to have 1/2 times 1/2 when I do that, right? I'm going to be putting that there, and so 1/2 times 1/2 is 1/4 is going to be out in the front. So my volume, now I did a trig substitution, not a U substitution, so my bounds are not going to change. So 1/4 theta equals 0 to theta equals 2 pi of 1 minus cosine 2 theta d theta. And then that's easy to integrate. So I'm like, okay, I can integrate that. So I get the 1/4, and then I integrate 1, and I get theta. And then I integrate cosine, and I remember that cosine stays the same sign. So this is going to be minus sine of 2 theta divided by 2. And so I have mine memorized that way. The integral of cosine 2 theta, I have that memorized as it is the same sign, sine of 2 theta over 2. Our book, when we were in Calc 1, they put a little a here, and they called it a theta. Actually, they probably called it, truth be known, they probably called it x. So I'm going to call it x right with them. You'll go find this in Calc 1, right? Ax, you can go find it in my Calc 1 notes, dx if you like. And then I have just memorized that this is equal to sine ax divided by a, and then plus a constant, I guess. I have bounds here, so I don't have to worry about it. Anyway, you do you on that. You probably have it down, and you're like, why are you telling us this? We're in Calc 3, gosh darn it. And well, because that's the kind of thing that I did not have down when I was in Calc 3. So I just assume you're like me. And so if you're beyond me, which probably most of you are, Hot diggity dog, I'm proud of you. And if you're not, then hot diggity dog, I just showed you why that was. And so it was a memory verse from Calc 1 is what it was. And so it was negative, so it stayed negative. And I'm going to be plugging in upper bounds 2 pi. So this is 1/4. And then I'm going to have the up bound is 2 pi minus sine of theta, and the up bound is 2 pi. So this is sine of 4 pi, right? 2 times 2 pi over 2. Minus the lower bound, I'll come back on it, 0. And then sine minus sine of 0 over 2. Now, good news, everyone. Good news, everyone. Good news, good news. The sine of 4 pi is equal to 0. And so this part is 0, hot diggity dog. And also sine of 0 is equal to 0. So that's great. This part's already 0. So it just becomes 1/4 times 2 pi. And if you multiply 1/4 times 2 pi, you get pi over 2 as your volume. And that's what I said the answer would be. So that's great. Did a lovely job on that. And so hand in the picture frame to hope it focuses. This is another one that it's asking us to do. I'm looking at that and I'm thinking, what the heck? And my algebra students are yelling at me, put the 2x with the x squared over here and complete the square. Believe it or not, that's what they're yelling because that's what we're starting to do. And so we're going to get here x squared minus 2x, because I want to draw this circle. And I'm going to leave a little space, plus y squared equals 0. So I've kind of rearranged it because I recognize that, well, it has x squared and y squared in it. It's a circle. So you want to get all the x's together. And you have to complete the square. I'm going to do the completing the square in whatever color pen this is. I don't know. It's kind of a teal, but I don't know if it's going to write teal. We'll see up here. No, it didn't. It kind of wrote blue. But whatever color it writes in is what I'm going to complete the square in. I don't know if you guys remember about completing the square. I call it in my algebra class the new C. And the new C equals b divided by 2 over squared. Sorry, not b divided by 2 squared. In our case, our b, you have to have a as 1. So when you do this, a has to be 1. If it's not 1, then you need to divide everything so that it is 1. And so, and if these didn't have the same coefficient, it would be not a circle, it would be an ellipse. So if you had x squared and y squared. So we're doing circles, so this should be the same. So anyway, so when a is 1, the new c is equal to b squared, b divided by 2, quantity squared. Rb is negative 2 over 2, quantity squared, which is negative 1 squared, which is 1. And so I'm going to add 1 right here, plus 1. And I'm going to have to add 1 to the other side, because what you do to one side, you do to the other. And then now I should be able to factor that, and it should be a perfect square. And so, so this factors as x minus 1 times x minus 1. Yeah, if you already know this and you're like, you're boring me, then I apologize. And so plus y squared. But I have to tell you that that's where I was when I took Calc 3, is that my algebra wasn't so good. And so if my algebra was better, then I would have done better in the class, I think. And I want to draw this circle, and it has center at 1, 0, and it has a radius of 1, the square root. This is radius squared right here, right? This is radius squared, which equals 1. And so this is the radius equals 1. So I'm going to draw that circle, and I have to tell you that I've had a hard freaking day, and I have drawn that circle wrong, because I don't know why, but I went over, and I didn't make the center on there, and I said, oh, it's up here at 1, and it wasn't. And so it's over here. This is the center at 1, 0. So there's the center of my circle, and the radius is 1. I tell you all my mistakes. I shouldn't tell you all my mistakes. I should leave it a mystery. I didn't make any mistakes at all. I'm perfect in every way, and everybody tells me so on my Instagram that I don't have. So there's my beautiful circle drawn perfectly. And we have y equals x. So I'm going to draw that in here. So I'm trying to ignore the circle and draw this halfway in between. My friends were telling me, hey, that's pi over 4. And it is. So this, what I am integrating over is this little tiny region right here. And so that I have. And so I want to draw out all of my r's and say what they are. This one's not a setup only. This one was solve it. But my picture right now is not as good as it could be. Now, I haven't got this circle in terms of the name of the circle. I don't want to call it x squared plus y squared equals 2x. And I actually don't want to substitute in here either. And so I actually want to substitute in for this circle back where I started. That was only to help me get it drawn. So this is x squared plus y squared. So if you're saying, hey, aren't you going back? And the answer is yes, I am, because that right there is r squared. And so this is r squared equals, and remember what x is? X is cosine, right? So this is 2, and this is x is equal to r cosine theta. And I'm checking because I'm like, I don't want to get that wrong. X is equal to x is equal to cosine. Yes. So this is the name of that circle. This is the name of the circle in rectangular coordinates, and this is the name of the circle in polar coordinates. And I can divide by r. R equals 2 cosine of theta. So that's the name of the circle in polar coordinates. So when I go here, I'm going to start right here, and I only want to go in this shaded region. I wish it was bigger, my shaded region, but I'm going to go and I'm going to hit that circle. Do you guys agree? That every point is going to start at the origin, and every point is going to go out and hit that circle. And what is the name of that circle? R equals 2 cosine of theta. So my r's are going to be trapped between 0, because this is all shaded in here, and 2 cosine of theta, because every single one of my r's is going to end on that circle. And I want to name it in, I want to know what r is in terms of theta. And so it's 2 cosine of theta. So I don't get to say that this length right there is always a specific value. That length is not always whatever the radius of the circle is, 1, right? Draw a few of them in there, and you might want to draw the circle bigger to make sure that you're understanding. Like this one right here that I'm drawing in there is definitely not a length of 1. And so how long are they? How long is that r in there that we're drawing out? How long is each one of those? Well, it goes from 0 to 2 cosine of theta, because it hits the circle. Then our theta, right? Our theta is going from here, right? Our theta, and it hits here at, where is that at? I guess they called that alpha, right? And so because we have 2 thetas, and do you guys agree that this is going to be pi over 2? So we're going to have, pi over 4, just checking you. And so I hope you're screaming at your TV right now. And so theta, right, is going to be trapped between pi over 4 and then I'm going to go all the way to here, right? And so from here to here. And so, and to get all of them, because this last one is just that barely when r is 0. And so do you guys agree that that's pi over 2? And so that's going to get all of them. And so our volume is going to be our thetas, which are going theta equals pi over 4 to theta equals pi over 2. And then our r's, r equals 0 to r equals 2 cosine of theta. And then here is where we want to replace. This is our height, right? So all of that doesn't have anything to do with what your height is. The height here is y. So every value in here, every single value in here has a y value, right? Has an x value as well. X value is not necessarily equal to the y value. And every single one of those y values is how high it is how high it is as it comes out of the paper. And so, but I don't want to write that in terms of y because I'm going to polar. And I remember that x is cosine and y is our sine. That's right, sine. So r equals r sine of theta. And then remember that dA equals, and I hope you're chanting it right now because it almost rhymes, r dr d theta. And then we have set it at, other than I would probably write that as r squared. If someone asked me to set it up, it would just look so much nicer. This one I was asking you to solve. I didn't give you the answer there anywhere. Let's see if we can solve it. And so get ahead of me. I hope you do. And so volume equals, pause the video and see if you can solve it. And to pi over 2. So this is going to be r squared sine of theta. I've just got the r times r is r squared, dr d theta. And I'm going to do my magic with my my blue pen, as this doesn't have anything to do with r. And so what happened to my other integral? Oh, sorry. 0 to 2 cosine of theta. And so I'm going to drag that through that integral and put it in the integral that does have to do with theta. And so I can pull it out because it's a constant in terms of r, right? And so that's the reason I can put it in front of the integral that has r in it. I'm going to do my purple pen and I'm going to put a box, because I'm kind of a boxy girl, around this and my arrow down because I'm just going to do that part. I decided I had a cough. R cubed over 3, right? I'm not going to ignore the sine of theta because I put it in the front. And my integral is going to go from 0 to 2 cosine of theta. Yeah, this is what I'm plugging in for r. So this is 2 cosine of theta raised to the third over 3 minus, and then when you put this in, 2 cosine of 0 over 3. Where did my raised to the third go? Sorry, just checking you. Did I forget to do the raised to the third when I did it earlier? I might have. Why did I put in 2 cosine of 0 there? I should have been putting in 0 and then raising it to the third. I think I've had enough math today without any food, and so I think I need some dinner. What will I have? I wonder to myself. Yeah, I'm sorry. I was supposed to be plugging in 0, up bound minus low bound, and I plugged in the up bound twice. And I'm blaming hunger is what I'm blaming, but it might not be hunger. It might just be craziness. And so here we're going to get 2 raised to the third is 8, and then cosine raised to the third, theta, over 3. And that's what I'm replacing in my in here. So don't forget my volume was theta equals pi over 4 to pi over 2. And we already had sine of theta there. So don't forget we had the sine of theta. And we're now having times 8 cosine cubed theta all over 3. And then times d theta. And the 8/3 I can put in the front, right? And so I'm going to move the 8/3 to the front. So I'm going to have this volume equals, and the 8/3 in the front. And I have a plan of doing a u substitution in order to solve that. Do you guys see what I would substitute in for u? I don't know if I could do it using a trig identity, because I don't really know any trig identities for cosine cubed. And so, but I do know that if I let u equal cosine of theta, then that would be u squared. And since the derivative of cosine involves a sine, it would kind of cancel some stuff out. I'm going to erase this part here so I can kind of make my plan. Better have a drink. I should have a cough drop. I have peppermint tea. Oh, it's so good. And so it's delish. I wish I could share it with you. But you probably don't want to drink after me, if you know what I mean. And so u equals cosine of theta, and du equals, now the derivative there is negative sine of theta, d theta. And I don't have a negative sine of theta, so it's gonna put in an extra negative. My bounds, I like to do my bounds, and so I always do my low bound first. It's my habit. I have my routine, and how I get them right is by trying to use the same routine. And sometimes I forget what I was doing and make a mistake and then get it wrong, and then I cuss. And so I say something like factor or function or other F words that are not becoming of a lady. And so I get cosine of pi over 4, which is the square root of 2 over 2. And then the upper bound is theta equals was pi over 2. And u equals the cosine of pi over 2. And I think the cosine of pi over 2 is 0, but you can check me on it using your calculator. And so I'm not going back to thetas. I'm going to stick with u all the way to the end here. And so I'm going to put a little line here so that that's kind of getting into that work that I had over there with my picture. So my volume, how I solve them on my paper is different than I solve them on the board. I know, because of how wide the board is and how long my paper is. That's the story. And I'm feeling really grateful that I had these on half page. And if I'd had these on half page, ooh, there'd be cussing. So I'm really grateful that I put these on whole page. When I solved them in my homework, I was able to fit them on half page because I was writing, I guess, smaller and all that. But anyway, okay. So I have the extra negative. I have the 8/3. So I'm going to put out in the front, my volume equals negative 8/3. So that's the extra negative, because I'm going to have sine of theta d theta. Here, sine of theta d theta. The 8/3 out in the front, the integral, right? And the bounds go from the low bound, square root of 2 over 2. You don't do them in numerical order. You do them in which one's the low and which one's the up, to 0. These are bounds for you. And we're going to replace cosine with u. So this is going to be u to the 3rd. We're going to replace sine of theta d theta with du. And I already put the negative that's extra out here in the front. So this is du. And then hot diggity dog, we have something that we can easily integrate. And so I'm going to do that. So this is negative 8/3. If I don't put that there, then I forget it, because that's how I roll. Over 4. You can reduce that, whatever you want to do, because the 4 and the 8 reduce with one another. What I'm finding I see people do is they reduce it, and then they're trying to save space. And so then they forget that they reduced it, and they reduce it some more, or divide by 4 some more. And so you do you. It doesn't matter on that, on however you're going to do it. So I am going to put these together and have just u to the 4th. And so when I do that, they're going to cancel and give me negative 2 over 3 u to the 4th. And then I'm going to be plugging in these bounds, square root of 2 to 2 and 0. So when I do, so this is my volume, I'm going to put this here, my upper bound minus my lower bound is my plan. And I know that I'm like the methodical show your worker, and the reason that I am is because it saves me from making more errors than I already make. So I already make enough errors, and then I'm hoping that if I make an error, and then in arithmetic or whatever have you, you guys will notice it, you will see it, and you will forgive me, is what I'm hoping, and not take a whole bunch of points off. And so, and that's kind of what the plan is there. And so the more work you show, the more chance you have of getting part credit. If I can't follow what you're doing, then I don't give you part credit. I can't get in your head and think what you got going on. Now, a negative times a negative, this part's 0, and so that's part gone. And a negative times a negative is a positive. I think I'm kind of glad about that because volume seems like it should be positive. And then here, 2/3, right, because I already got rid of the negative. So I'm going to put this in my calculator because I've had too much math today and not enough food. And so, what would I eat? I had a friend who said that he would bring me McDonald's. He said that would fix me up and make me feel better. And I'm not really convinced of that. Or he would bring me some soup that he made. And I'm thinking that might be better. And so I get 1/6 when I put it in the calculator. And so the volume here is 1/6. Hot diggity dog. Yay, yay. The crowd goes wild. How long is this video? Already an hour and 5 minutes. Are you kidding? Seriously? Oh, it's because I solved for solve. Fast forward through those. So this is just a little picture showing that, hey, it could be a function here and a function here for R. It's a possibility, and then you could put those functions on there. I don't know why I put that here in the notes because I've already had that, right? We did that just here a second ago, and so I'm here, right? See here, it's saying that it doesn't have to be a constant; it can be a function. And look, there it is being a function. So I probably should have had this earlier in the notes. Anyway, so forgive me. And that's what we have. So this one is a setup only, and in fact we can't solve it because they didn't tell us what f was. And so they said f is an arbitrary constant and an arbitrarily continuous function on R. And R is the region bounded by x squared plus y squared equals 4. And also x squared plus y squared equals 2y in quadrant 1. And here I have a typo. I know, you're like, will you fix these typos for future people? And the answer is yes. So if you're doing this and you're saying, oh, you already had that there, it's because you're a future person and I've already fixed it on there. But there's no directions here, right? It says this and then it doesn't have any directions. And so I should have had as directions, I should have had something like this. Set up the double integral, or just the integral, but it is a double integral, so I'll say double integral, to find the volume. So I should have said that as some directions. And so here we will go. In order to get it, we need a picture going, and you'll just have to take my word for it that I've drawn this so many times that it's better if you draw it big. And so since we're not going to solve it, I only have half a page, but it is better if we draw it big. So I have this first circle, x squared plus y squared equals 4. So radius squared equals 4. So radius equals 2. So I have that circle, and I'm going to come down here so that I have room, and I'm going to put that right here. So radius is 2, and I'm drawing it big because I have drawn this many times before, and I have experience. So if you're like, how did you know to draw it big? Well, the first time that I did the problem, Exhibit A, I did not draw it big and then had to redraw it big. So that's how I know to draw it big. So just because I've done the problem before. So forgive me on that and not wanting to draw it twice right here in front of you guys. Okay, and then the other one, well, that's a circle as well, and my algebra students are working on that. So we're going to subtract over the 2y, leave a little space, and we get equals 0. And I hope that you're kind of saying, oh, well, we have to complete the square, and oh, heavens almighty, you already did that one, right? We had -2 on the other as well. This is +1, so +1 here, and you're right. And so this gives us x squared plus, and then this is y minus 1 quantity squared equals 1. So if you are rusty on your completing the square, come by and see me, and I'll help you with it. And but I went through that with the new C and all of that. This is the one that I kept drawing wrong. I said I was drawing the other one wrong. Well, maybe I was drawing them both wrong. But this one has center. You never know about me. 0, 1. So the center is up here, 0, 1. And the radius is 1. And so this circle is right here, radius of 1. So this is 1, this is 1, radius of 1, out here 1, probably maybe a little further, and here 1, and here 1. I'm kind of drawing it here. Ooh, this is a circle. I bet yours is beautiful. Don't show me your pictures, them being beautiful and mine not being beautiful, because it'll hurt my feelings and make me feel inferior. Okay, so we're wanting the area that is, and I know that's going to be a volume, but what we're wanting is to find the volume over the region that's trapped by these two. And so I have this circle, right, and I have that circle, and so it's this region out here. I don't know if you guys are buying that, but it's this region out here that that is bound by the two, and so that's the region that we're looking at. Okay, so now I want to say what my R is, and I want to draw a really typical R, and I'm going to draw my R right through here. And so you notice that it's not hitting, it's an error, and then it goes through and it hits the one circle, and then it hits the other circle. So I need the equations of those circles. Now the one equation of the circle is just simply R equals 2. So that circle is pretty good. The outer circle is R equals 2. And the inner circle, well, what the heck is the inner circle? I'm going to put that here. Just like we did on the other, I don't want to use this, right? I want to say that I want to use that x squared plus y squared equals r squared equals 2y. Now, y is, what was y? Y was it cosine or was it sine? I think it was sine. Hopefully I'm not wrong. And so this circle, that inner circle, that's this one right here, is equal to r squared equals r sine of theta. Now, when I do my bounds, I need to have solve for r. So I don't know if you've noticed I've been solving for r on all of these. So I needed to be solving for r. So I divide each one of these pieces by r, and I get r equals, was there a 2 that I'm missing? Yeah, there was. I don't know why. I did not put the 2. 2y, right? And so 2r sine of theta. I'm really lucky that I saw that. And so 2 sine of theta, right, when you divide by r. So that's my inner circle right here. So when I go this distance, I have gone r equals 2 sine of theta. So I'm going to have down here is where I'm going to write it. My r's are going to be trapped between 2 sine of theta and then continues on out to 2. And so out to the circle 2. That one wasn't as bad. The radius there is just 2. And so, and you can kind of check, do all of them fit that? If I draw another one, well, it goes from here, the origin in air, right? And then it hits that circle, which was 2 sine of theta, and then goes on to r is 2. Does it do it over here? And I haven't got it drawn. I look on your picture, not on mine, but in my picture here, yeah, it does. It does it even here. And so now we want to do our where theta goes from, and then we'll be ready to put all this stuff in. Gosh, my picture was a little better when I did it all by myself, and that makes me mad. Anyway, but that's my value that I'm really looking at, right? That's what my r is trapped between. And so my theta, well, where's my theta go from? It goes from here at 0, right? And so, and this is, this circle is centered at the origin, so I don't really have to worry. And so I'm going from 0 to where? So I'm going to go here from 0, and my thetas are going to go all the way to, I hope you're saying pi over 2. Okay, so my setup for my volume is going to be my theta's on the outside, so theta equals 0 to theta equals pi over 2. They didn't tell me what the function was, and so they didn't tell me what z was here. So I want it in terms of r and theta. Does it go r theta or does it go theta r? I don't know what order that goes in. I should know that because I'm your teacher. But I don't right now. I don't know that it matters. I'll just call it F, and then you won't know that I don't know. I think it might be R theta. I'm not sure. And then dA, right? Oh, I didn't get my bounds for R. That's the hunger. And so 2 sine of theta to R equals 2. Well, when I did it at home, I put R and then theta, so I'm going to do that. And then R d theta. And so, hot diggity dog, there we have that. And so, perfect, beautiful. And then I made a note to myself that I needed one that it was a little harder. I'll show you what I put. But this video is getting too long. Need a polar example that shows how bounds for theta can be tricky. And so far, none of my bounds have been tricky. And I have that tricky example here, but I think I'm too hungry and too tired. There it is. So I called it nasty example. I wish I had put on the notes. And so I think I will make another video with the nasty example that I wish I had put on the notes. We have this one last idea, and then this video is over, and I'm going to get some food. I hope that if you're not rested or full of food, that you go and do all of those things as well. I ask you, this is the basic idea: when does a volume equal area? And so for example, if I did the volume of a cylinder, it's equal to pi r squared h. And then the area of a circle is equal to pi r squared, right? And so can you think of a time that this volume and this area would be equal to one another? Just giving you an example on it. And I hope you're saying when h is 1. And so when h is 1, when the height is a constant, when h is 1. So I think in Calc 2, that you found the area of polar regions. And so this is another way that you can find the area of polar regions, is by integrating with a height of 1, because that would be a constant height of 1. And so that would give you an area that's the same as the volume. And so you would be really finding with the double integral the volume, but they would be equal to one another because your height was 1. So that's the idea. And so that's basically what they're saying here, is integrate 1 dA is what that's saying. And then you will really be finding a volume, but you'll really be finding the area. So they asked me to use a double integral to find the area enclosed by one loop of the 4-leafed rows, r equals cosine of 2 theta. And so first I have to draw that sucker. And I want to get one complete leaf on on this rows. You can go on Desmos and you can kind of draw this, but I know because Susie could tell Oscar had a heap of apples. No, not because of that. All students take calculus. That cosine is positive in the first quadrant and also in the fourth quadrant. And so one leaf of my rows, is going to be in the fourth quadrant and also in the first quadrant. And so when I start picking to kind of draw this, I have to tell you that it's been a really long time since I've drawn these. And so I'm going to be picking values of theta, and I'm going to be putting them kind of on here, and making a little drawing of it. But the reason I'm picking negative values of theta is because cosine is positive. I'll put that right here. All students take calculus. Cosine is positive in the first and the fourth quadrants. So I'm wanting to get the positive values in the first and the fourth quadrant that are going to create one leaf of this rose. I think that I at one time knew how many leaves this rose was going to have, and maybe you know how many leaves this rose is going to have, but I'm only trying to draw one little part of it. So I'm going to pick. I'm going to put R here, and I'm going to put theta here just for my drawing purposes, and I'm going to pick just some values. I'm going to pick pi over 8 negative. And, I want to pick negative pi over 4 first. Maybe I want to pick negative pi over, maybe I want to pick negative pi over 2 first. Negative pi over 4, we'll talk about which ones I really need. Maybe negative pi over 8. Maybe 0. Maybe pi over 8. And maybe this is too many points in the way I've got them lined up here. Boy, this is never going to fit on there. Sorry, friends. Sorry if anyone wants to come and help me with my craziness. That'd be really great. Okay, so I want to find the R value plugged in here. And so this would be R equals cosine of negative pi, which is equal to, is that equal to -1? And negative pi over 4, if you plug that in, is 0. Negative pi over 2 is the square root of 2 over 2. Is it negative? Or is it positive? It should be positive. And then at 0 is cosine of 0, which is 1. Pi over 8 is the square root of 2 over 2. Don't worry, I'm going someplace with this. This is 0, and this is cosine 2 times that is pi. So this is -1 as well. Okay, and I'm going to do my drawing over here. And so I really like these zeros, and that's really where I want to start, is at these zeros. So when I'm at an angle of negative pi over 4, so negative pi over 4 is in the center here, I'm at 0. Radius is 0. So that's negative pi over 4, and I'm here at 0. I didn't really want to start at -1. I want to start at 0, so I had to find the 0, and I found it. Now negative pi over 8 is like half of that distance, and I just put that there, and I'm at a distance of the square root of 2 over 2, which is like 1.4, and so I'm putting that just right here. Okay, so this one here, I was at 0, right? I'm just kind of drawing it out there. And then at 0, I'm at 1. So if you kind of follow me, I'm going here is what I have so far. It's not, that shouldn't be, that's a bad angle. Sorry, just checking on you. This distance should be probably really somewhere in here. Maybe it's better. I don't know. Okay, and then pi over 8. So here, halfway here, and then here. And then so here, I'm here. Right, just kind of following around. And then pi over 4. I'm back to 0. Oh my gosh, that's the worst leaf I've ever drawn. Look, I did it better when I wasn't being criticized. And so there is my complete leaf. And hi Susie. And I'm going from negative pi over 4 to pi over 4. So I wanted to go from 0 to 0 to get that complete leaf. Okay, so I'm going to set my, this is my volume, which is really going to be, I'm going to show you. So my volume, I'm going to integrate over 1. I'm going to go from R equals, now R goes from here out to that curve. And that curve is the rows, which is cosine. So this is my rows right there. So it's going from 0, my R, to my rows, which was 2, not 2, cosine of 2 theta. And so I'm going here from 0 to 2 to R equals cosine of 2 theta. And then where's my theta going from to get the whole rows there? It's going from negative pi over 4 to pi over 4. How did I know to start looking negative? Is because cosine is positive in the first and fourth quadrant. And so that's how I knew to start looking positive to get the whole thing. Otherwise, I was going to get half of one part down here and whatnot. And remember, this is going to be r dr d theta. This is my height. My height is 1. That's what really makes this an area, right? Because the height is 1. And we're going to go from, where did I say? Again, negative pi over 4. So theta equals negative pi over 4. Oh my gosh. 0 equals negative pi over 4 to pi over 4. I hardly can fit that in there. So now I just have to integrate 1 times r, and 1 times r is r. And so when I integrate that, I get r squared over 2, and from 0 to cosine of 2 theta, right? And I like to put a box around this to show you that that's the part that I'm doing, right? And this is what I'm doing right here. And I'm going to put a box around that as my answer. So this is going to be cosine squared 2 theta, right? Because I square r. And so cosine squared 2 theta. If you're like having trouble with that, it's this, right? It's cosine 2 theta squared. And I wasn't the one that came up with the notation of putting that squared right there. Whoever came up with that, putting the notation of the squared right there, it's not the best notation in the world. I'd like to talk to them, a sternly written email to them, and then minus, and then 0 squared over 2. And I was almost going to put cosine in for that 0 there because I'm hungry and I'm tired. My basic needs have not been met. And so that's just going to be that. And so my area is going to be pi over 4. How did I fit that in there? Goodness. To pi over 4. This is negative pi over 4 to pi over 4. And I'm going to be integrating cosine squared 2 theta over 2. And you can put the d theta, and you can put the 2 on the outside there. And then we're going to use that that identity, that trig identity that we've done before. I'm going to write my trig identity down here, trig. So I'm going to get triggy with it here. And my trig identity is normally this. Cosine squared x equals half, and then it's 1 plus cosine 2x. But what I have is I have 2 theta. So you want to double that, so that'll be 4 theta is what that'll be. So this is going to be the integral from negative pi over 4 to pi over 4. And this is going to be the half out in front. So I'm going to put the half out in front. There's the half. And then here's the half that's out in front. And then the next thing is to use this identity. I have it just barely where you can just barely see both of them. So half, do you guys agree? Half times half is going to be a fourth right there. And then I'm going to have 1 plus cosine of 4 theta d theta. Not enough parentheses there, but there I have it. Hot diggity dog. The 1/4 is out in the front. So my area, which is equal to my volume with a height of 1, right? is equal to, I got the 1/4 out in front. So this is the 1/4 out in front. The integral of 1 is theta. The integral of positive cosine of 4 theta is equal to, it's the same sign, and it's sine of 4 theta divided by 4. And I'm going to do the bounds negative pi over 4 to pi over 4. And so this is going to be 1/4. And then I'm going to have, do you guys agree? I'm so tired and you're so tired, but do you guys agree that if you put in pi over 4, that's a sine of pi, because 4 times pi over 4, which the sine of pi is equal to 0, right? And then the sine of negative pi is also equal to 0. So this part is 0 for both of our bounds. And so it really is just going to be theta. I hope that you buy that. Upper bound pi over 4 minus lower bound negative pi over 4, right? What happened to the signs? Remember what happened to the signs? They were 0 at these two bounds. What if they weren't 0? Well, then I wouldn't be able to do this. I'd have to do it more carefully, right? And put in what they were, and maybe I'd have the square root of 3 running around or something. I don't know. It could get ugly. And so when the dust clears there, I have pi over 4 plus pi over 4, which is 2 pi over 4, which when the dust clears there is pi over 8. So I hope that's what you got to. So this is 1/4, and this was 2 pi over 4, which is pi over 8. And so that's our area of one little leaf. If they asked us for the area of all of the leaves, I know that's something that they asked you in Calc 2, then I would have to draw it so that I knew how many leaves there were. I would do one of them. That would probably have been a better thing to have done, to have drawn the whole thing and then figured out where it was instead of being a smarty and doing that. Anyway, I have on the next page, and I'm not going to do these for you. You have to do them for yourself. I'm not your Calc 2 teacher. I'm your Calc 3 teacher, and this is stuff that you're supposed to know, is what these things make. So these make cardioids, and so I hope that you go on Desmos and convert Desmos into, I'm going on MacBook screen here, and convert Desmos into right here with the tool icon. No, it's not the tool. Which one is it? Oh, did this go to sleep and crash? It did. It crashed. Oh, wait, I'm not on the right screen. It didn't crash. I'm not on the right screen. So here, sorry, I'm not on the wrong screen. So when I click on the tool icon, I can choose that polar grid right there. This is the rectangular grid, and here's the polar grid. And so I chose the polar grid, and then I put things in with R and cosine. And so I didn't put in the 1 here, but I'll come here and I'll click on it. 1 and then plus, and then it makes a cardioid. And so what I'm hoping that you'll do, I have y equals x in here. It just says a little reference of what, a lot of times we have that. So I'm hoping, no, you got to go on this screen here, and then you click on pay-per-view. So I'm hoping that you'll go on Desmos and that you'll put all of these in and see what they look like. And then I'm hoping that you'll go and you'll do these. These are polar roses, and that you'll use different values of A and use M to be odd and use M to be even. And that's with cosine. This was with sine. Use M and odd, odd and even to give it a try to see how they look. See if you can kind of remember back. I know you did them in Calc 2. And then here our limicon, how do you say that? I don't even know. And then our limescape. And so use different values of A and give it a try. I think it'll be fun. I'm done. I'm so done. I'm so done. And I'm going to get something to eat. I hope that you're going to get something to eat. And then later I might make a video with that nasty problem there. If you want to do that nasty problem without my video, there you can pause on it and you can go and do it. I don't recommend solving it unless you want to get really Calc 2y on it. It would be the hardest integral that you solved in Calc 2, but all can be done using Calc 2 on it. And so it is definitely a setup only on it. And so I will see you guys next time. Oh, wow, that's long. Okay, sorry. Okay, I apologize for the length. And how do I stop? Stop.